Dear viewers, in this video I have come up with the back exercises of chapter number 2 NCERT Science, that is matter around us pure. So let's come to question number 1. Which separation technique will you apply to the separation of the following mixtures? So I am telling you one by one and I am going to write the answers in the notebook. Number first is, if you have read the chapter, it is very easy to identify the separation methods. Number first is sodium chloride from its solution in water. So number first answer, A part, is evaporation. If you evaporate the solution, the water will be evaporated and the salt will be left behind. Ammonium chloride from mixture of ammonium and sodium chloride. Ammonium chloride is a sublimable solid, so the second method involved for separation is sublimation. C is small pieces of metal in engine oil. That is very simple. By filtration we can separate, because one is liquid and one is a solid substance. So filtration. D part is different pigments from an extract of flower petals. So pigments are very you can say colored substances made up of two or more different substances combined together, which can be separated on the basis of dissolution of these substances in a solvent, which is done by chromatography. Next is butter from curd, is done by centrifugation method, which is based on the densities of the substances. F, answer number F is oil from water, is done by separating funnel, because both liquids differ in their densities. Next, G is tea leaves from tea. That is again very easy. That is filtration method that we generally employ in our homes to strain the tea from insoluble part the soluble part. Next is iron pins from sand, because one magnetic material is involved, so magnetic separation is used. Next is wheat grains from husk, that is done by winnowing. And J part is fine mud particles suspended in water, which is separated by sedimentation and decantation, again based on the densities, because mud particle will gradually settle down at the bottom of the tank and you can separate it by sedimentation and decantation. Next is question is, write the steps you would use to make the tea. Use the word solution, solvent, solute, dissolve, soluble, insoluble, filtrate and residue. So I am just repeating out the steps, and you can listen and you can write it in your own words. All of you know how to make the tea. So number first step is, take some water, or you can write take some solvent in a pan and heat it. Then add some sugar, that is solute. Add some sugar, that is solute, and boil so that sugar is completely dissolved. Now add tea leaves in the solution and boil the mixture. Now add tea leaves in the solution, boil the mixture, and now you will add the milk and boil again. Now filter the mixture, so filter term is used. Filter the mixture and through the tea strainer, and you can collect the filtrate or soluble substance in a cup, and the insoluble tea leaves will remain behind as a residue in the strainer. So you can write down in your own words, just using all these keywords to how to make the tea. Next question is, you have been given a table, and in this table you have been given 4 salts with different solubilities at different temperatures. Now they have asked you, A part, what mass of potassium nitrate would be needed to produce, what is solubility, it is the amount of substance in gram needed to saturate 100 gram of water at a particular temperature. So here the potassium nitrate saturate at 313 K solubility 62 means 62 gram of potassium nitrate will saturate 100 gram of water at 313 K. So you have to find how much potassium nitrate will saturate 50 gram of water at 313 K. So answer number 3, A part is 100 gram of water is saturated by 62 gram of 100 gram of water is saturated by 62 gram of potassium nitrate. So 50 gram of water will be saturated by how much gram of potassium nitrate? That is 62 into 50 divided by 100, and you will get it as 31 gram. Okay, so answer is 31. In this case, 31 gram of salt will require to saturate the 50 gram of water at 313 K. Pragya makes a saturated solution of potassium chloride in water at 353 K and leaves a solution to cool at room temperature. What will you observe as the solution cools? You will get the crystals of the potassium chloride will separate out on cooling. On cooling, because it is a saturated solution, so on cooling the solution you will get the crystals of potassium chloride. So you will write crystals of KCl will separate out on cooling the solution. And why this happens? Because the solubility of KCl decreases with the decreasing temperature. As the temperature decreases, the solubility of the salt goes on decreasing as solubility decreases with temperature. Next is find the solubility of each salt at 293 K and which has highest solubility. So you can see this from the chart itself at 293 K, and you can see the solubility of each salt. The maximum amount of salt is dissolved, that is ammonium chloride. So obviously the answer third will be ammonium chloride, which shows the maximum solubility at the given temperature, that is 293 K. What is the effect of change of temperature on the solubility of salt? If you will observe clearly this table, you will see there is a gradual increase in the solubility with the temperature of different salts. All the solubilities are increasing with the temperature more or less. So the observation is effect of change of temperature is with the increase in temperature the solubility of salts increases. So you will write solubility of salts increases with increase in temperature. Or you can write vice versa also, that is it decreases with temperature, decrease in temperature, or increases with increase in temperature. Next is you have to define the following by giving examples. So I am just telling you the definitions, since you can easily find out from your books also, but I am just telling you the definitions for saturated solution, pure substances, colloid and suspension. What is a saturated solution? A solution in which no more amount of solute at a particular temperature can be dissolved, like sugar solution. If you keep on dissolving sugar in water, time will become when the sugar will no more dissolve in that water, and that is termed as a saturated solution. Next is a pure substance. A pure substance is made up of a single type of particles, and you cannot divide it into or you cannot break it into its constituent particles. All elements and compounds come under pure substances. You can write any example of an element or a compound in this case. Colloid. Colloid is a heterogeneous mixture in which the solute particles cannot be seen with the eyes, but they are big enough to scatter the light. They are able to scatter the light. So the solute particles are termed as the dispersed phase, and the medium in which they are spread is called the dispersion phase. For example, here you can write colloid is milk. Suspension is again a heterogeneous mixture in which the solute particles do not dissolve, but they remain suspended throughout the mass of the solvent, and the particles are visible to the eyes. For example, if you dissolve sand in water, then that is termed as a suspension, because sand particles are easily visible to our eyes. So you can see the definitions to your book and easily quote 1 or 2 examples. Now you have to classify. Question number 5th is classify each of the following as homogeneous or heterogeneous mixture. So let's see first. I'm just speaking orally. Okay, number first is soda water. Soda water is a homogeneous mixture because you cannot see the particles of constituent material separately, so that is a homogeneous mixture. Wood is a heterogeneous mixture. Air is a homogeneous mixture of gases. Soil is again a heterogeneous mixture. Vinegar is a homogeneous mixture, and filtered tea is a homogeneous mixture. How will you confirm that a colorless liquid given to you is a pure water? Because if pure water has a sharp melting point, sharp boiling point, that is 100 degrees Celsius. So if water boils at 100 degrees Celsius, it is a pure water, and if it boils at greater than 100 degrees Celsius, then it is containing some dissolved substances in it and it is not a pure water. Now let's see another questions. They are objective questions only, so I will discuss it orally only. Which of the following materials fall in the category of a pure substance? Ice is a pure substance. Yes, ice is a water, made up of water, and water is a compound, so water is a pure substance. Milk is not a pure substance, it is an emulsion. Iron is a pure substance. Hydrochloric acid is a pure substance. Calcium oxide is a pure substance. Mercury is a pure substance. Brick, wood and air are not pure substances because they are mixtures of some other thing. So the pure substances here are ice, iron, calcium oxide and mercury. Hydrochloric acid also you cannot term it as a pure substance because it is made up of water and HCl gas. So again this is not a pure substance. Identify the solutions among the following mixtures. Soil is not a solution. It is a heterogeneous mixture. Seawater is a heterogeneous solution. It is a heterogeneous mixture also and it is a solution also. Air is a homogeneous mixture of 2 or more substances, so it is homogeneous, but it is not a solution. Soda water is a homogeneous mixture, or you can say it is a solution. So out of these, seawater is a solution, soda water is a solution, and air is a solution. Why? Because all these are homogeneous mixtures and rest are heterogeneous mixtures. Which of the following will show Tyndall effect? Tyndall effect is obviously shown by the colloids. So out of all this, milk and starch solutions will show the Tyndall effect because they both are only the colloids. Now you have to classify the given elements, compounds and mixtures into its proper category. Sodium is an element, soil is a mixture, sugar solution is a mixture, silver is an element, calcium carbonate is a compound, tin is an element, silicon is an element, coal is made up of carbon. So you will write it in, but coal is made up of some more other substances also, so it contains impurities also. So coal is a mixture, air is a mixture, soap is a mixture, methane is a compound, so it will come under compound, carbon dioxide is a compound, and blood is a mixture. So these are categorized into elements, compounds and mixtures. Element is a pure substance, compound has a definite formula, definite composition, and mixtures are made up of 2 or more substances. Which of the following are chemical changes at which cannot be reversed back? The growth of plant is a chemical change, rusting of iron is a chemical change, mixing of iron, filings and sand is a physical change, cooking of food is a chemical change, digestion of food is a chemical change, and burning of candle is a chemical change. So all these are chemical changes and rest are physical changes because there is no change in the chemical composition of the substances, or either a new substances formed or not formed. So depending on these characteristics you can easily classify the changes. So these are the exercises of this chapter. In the next video we'll deal with the exercises of chapter number 3rd, that is atoms and molecules.